All right. Testing, 1, 2, 1, 2. Okay. Hope everyone is doing well. Welcome. So I know exam 2 was just due, so more than likely I'll update grades within the week. Yeah, so we're just going to kind of move on to the next section. Let me see, we got exam 3, exam 4. So I think we have about 5 or 6 sections remaining. We don't have that many remaining. Let me see. So we're moving into chapter 2 today. 3 sections. Yeah, it's only 5 sections remaining. Right, so that's essentially 5 weeks of lecture. We still have two more exams, exam 3, exam 4. No, I think it's only 2 more exams, exam 3 and the final. All right. Yeah, that sounds more accurate. We get the Thanksgiving holiday off. So let's just kind of move into the next chapter. This one. Okay. So we're moving in, and as always, if you have questions, feel free to either unmute yourself or type in the chat to get my attention and we can talk about it. So we're moving into chapter 2 on polynomials and rational functions. And so this week we're going to be focused on section 2.1, quadratic functions. A few objectives. 1, graph a quadratic function in standard form. 2, graph any quadratic function. And 3, solve problems modeled by quadratic functions. Get this message from the dealership talking about, this is your friend from Toyota South. I'm like, if you were a friend, you wouldn't be charging me anything. Sheep and wolves. A wolf in sheep's clothing, right? Anywho, okay, let's see what it's looking like. So what do we mean by a quadratic function? It's a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, where a is not equal to 0. We call this a quadratic function. Okay, so I mean, I know we've been working with this on some level, So this quadratic function where we have f of x equals a times x minus x squared plus k, where a is not equal to 0, we say that this is in standard form. The graph of f is a parabola with a vertex h comma k, and the parabola is symmetric with respect to the line x equals h, called the axis of the parabola. Sometimes you hear me refer to it as the axis of symmetry. If a is positive, the parabola opens up. If a is negative, the parabola opens downward, right? So this is what we call a quadratic in standard form. I feel like this is the easiest way to graph a quadratic. There's a couple of ways you can kind of go about it from here. The h comma k is going to be what's called the vertex of the parabola, right? So you know how the parabola is like a U-shaped curve. That point of that turning point is the vertex, all right? If our a is positive, if our leading coefficient is positive, that means the parabola opens upward. If a is negative, that means the parabola opens downward. So what you could do is start at the vertex at your h comma k, plot that point, and then just use the axis of symmetry, right? So if we're using the axis of the parabola, whenever we get a point on the left, we automatically get on a point on the right, and vice versa, right? So every time you get any additional points, you get 2 for 1. So then you just plot those few symmetric points on either side of the axis of the parabola, and then that can be your graph. Another way that you could graph this is through transformations, right? So in the standard form, let me see. You can start with like just a standard parabola with the vertex at the origin, and then use transformations. You have your inside manipulation, your vertical stretching or flipping or anything of that nature, and then your vertical translations, right? So And then there's even the third way. I mean, it kind of parallels the first way that we talked about it, but you can also just plot points, right? So, but a quadratic in this form is going to be the most simple way to graph it, because again, it identifies the vertex, and there are a lot of different concepts that you can use to graph it. Find the standard form of a quadratic whose graph has this vertex and passes to this point. Okay. All right. Okay. All right. So we can start by using the formula that we had on the previous slide. So if you have a formula sheet, it's a good idea to go ahead and add this to your formula sheet someplace, maybe in the back of your notebook where you can easily access these guys. So when you need them, they're right there ready to go. So the standard form of a quadratic, a times x minus h squared plus k. Okay. So they say the vertex is negative 3/4. So this is our h, this is our k. And passing through the point -4, -7. So this is our x and this is our y. Let's plug in the information that we're given. Okay. I don't think we've been given any information on a, so I'm just going to bring that down. Let me see, x minus h squared plus our k. Okay. So first, everything equals y. So I replace each component with a blank set of parentheses, and then I'm going to do my substitution by plugging into the blank parentheses. So my x is -4, my h is -3, my k is 4, and my y is 7. So again, the parentheses helps us to minimize our chance of making mistakes when it comes to these signs. So then here, we got a double negative at play, right? So double negative becomes positive. Okay. So then -4 plus 3 ultimately is -1. Squared is a positive, right? So I'm just not writing all the details. Okay. So you subtract 4 on both sides. I think a equals 3. Just going to make a little divide there. So then if we put all this together, I'm not feeling that. I'll just write it here. This is fine. So our a is 3. X minus h, our h is -3. So x minus a -3 becomes x plus 3 squared plus 4. Okay. I can't think of anything else there. So here we're asked to sketch the graph of this quadratic. It looks like it's already in standard form. We need to do a little bit of a manipulation first. Because remember, the standard form is in this form. F of x equals a times x minus h squared plus k, right? But they have x plus. So we do need to rewrite it a little bit. -3, that's going to be x minus a -2 squared plus 12. Okay. So that now we have the coordinates of our vertex. It's going to be -2, 12. The leading coefficient is negative. So the parabola opens downward. I'm just going to do a rough sketch. So if the vertex is -2, 12, just quickly to yourself, what quadrant should we be in, right? If the vertex is -2, 12, we should be in quadrant what? 2. And the parabola should open downward. So that's just giving me a sense of how to prepare my graph. So I'm gonna focus on quadrant 2. So we're gonna say this is our positive x in this direction. Again, this is just a rough sketch. This would be our positive y in this direction. -2, 12. So I'm gonna go 2, 4, 6, 8, 10, 12, 14, 16. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So we have our origin. These went by 2s. And these went by 1s. Okay. Let me see. So we got a vertex of -2, 12. So that's going to put us about here. So that means that this is going to be our axis of symmetry or axis of the parabola. Okay. Let's go style like this and make it a little bit smaller. That's decent. Okay. And this is x equals -2. This is just the axis of the parabola. Okay. Again, our A is negative, so that means the parabola opens downward. I'm just going to use the axis of symmetry. So I'm going to choose, like I'm going to step one unit to either side to get a point, and then automatically gives me a point on the other side. Or let me see. It looks like our y-intercept might be way down there. Let's do when x is -1. When x is -1, plus 2 is 1, squared is 1, times -3 is -3, plus 12, what is that, 9? So when x is -1, y is 9, so that's about here. So the way we use the axis of symmetry, if we go to the right by 1, we're at 9. That means that when we go to the left by 1, we should also be at 9. So this point here, okay? Let's see when x is 0. When x is 0, plus 2 is 2, squared is 4, times -3 is -12, plus 12 is 0. So it looks like we passed through the origin. So then when we go 2 to the right, we're at 0. That means when we go 2 to the left, we're also at 0. And that's enough. So then we just connect these points with the smooth curve. Smooth as we can make it, all right? I don't know. Going to the right. Let me see if I can do a little bit better than that. Maybe if I turn it, let me see if I turn it like this. I don't know if this is any better. It feels better. All right. Instead of drawing my parabola vertically, I turned the tablet to the side and drew it sideways, and for whatever reason, it felt better. Okay. Let's see. Yeah, okay. So that was just a showcase on us using the standard form of a quadratic. I kind of want to do a showcase. I mean, I feel like yeah. I want to do a showcase. Let's do a showcase. So let's see what we got here. Come on. Let me get rid of all this stuff. I don't need all this stuff. 18 tabs. Okay, let's start off with this guy. So first I want to showcase in my TI-83 plus, I guess I gotta pull it back up. I agree, choose the file, choose the file. No, choose the file. I gotta think about where it is. I'd have it here. Oh, this one. Thought I moved it, but I guess I hadn't. Because if it's not here, I got another place it could be. Okay, that's okay. I go here. Oh, where is that folder? Right there. This one. Okay. Yeah. Okay. All right. So we got our emulator file. All right. So let me just showcase this in like a TI-83 plus, right? So if we go to our y equals, it's not as straightforward as just typing it in. I mean, you still have to have some level of like awareness of what you're doing. Because you got to get the window right, things of that nature for it to behave properly. So we got a -3 parentheses x plus 2, close parentheses, squared, plus 12, okay? So then what I'm going to do, I'm going to match my window, this window to our window. So our minimum, I'm going to go -5. Our max, I'll probably just go to 2, just to, capture similar to what we have. X's are going in steps of 1. The Y minimum, I'll probably go down to maybe -2. The Y max, probably I'll go to 16, that's fine. But Y's are going in steps of 2, okay? Okay. So now I'm going to hit graph. Notice we got the same thing. We can even plot points. If we go to the table, right, we can see the points that we plotted. For instance, when X was -2, so you see the -2, 12. -3, you see the 9, 1, 9, right? So there's a demo using a TI-83 plus. And then I also want to do a demo using decimals. Just real quick. My keyboard has been throwing tantrums lately, man. I'm not using it right this second. Some of my keys are just, for whatever reason, aren't working. But I'm going to try it now. I'm so sick of this stuff because it's clear that they intentionally designed these things to break down just for the sake of capitalism, to just try to get you to come back and buy more. This is actually a good keyboard, but it breaks down after about a year or two. This is maybe the second or third one I've had. I don't know. It's just I have to get into production so I can make quality stuff that just lasts forever. I don't care about the money. I just want this stuff to work. I'm sick of this stuff intentionally breaking down. I'm sick of it. Anywho, f of x, see, let's see if I get this working. Nothing. People for this. Okay. All right. So then f of x. Let's see, that's what I mean. Some of my keys are not working, but we also have a workaround. Equals. Oh man, my equals isn't working either. That sucks. -3. Man, this is really irritating. Does that work? Okay. X plus 2. Plus 2. Okay. Squared. I don't think that's gonna work. Okay, that works. Plus 12. That doesn't work. So plus 12. Okay. And then for the window, I mean, we could adjust it. I'm just gonna. It looks a little weird because of the window, but yeah, I think we're good though. But essentially we have the same thing, all right? Okay, so that's fine. Guess I just have to get another keyboard. Sick of these keyboards. I gotta get a quality one. They're cheap. They're like $25. I like them. They're compact, but I don't know, for whatever reason they just, anywho. Okay, so let's see the way the textbook approached this guy. Sketch the graph. Okay, so then they identified their A and the coordinates of the vertex, -12 and 2, -2 and 12. I think they pretty much did the same thing that we did. It looks like. Oh no, they did a few additional things, or they did a little bit different. They did identify the vertex, which we did. We did that same step, but they went on to use the x and y intercepts, right? They used the x intercepts, so that means you set y to 0 and solve, which would have been fine, right? So you get the 0 and -4. We got those same results. Okay, and then they found the y intercept. It's the origin. We got the same image. Okay. All right, sketch the graph of this. All right. So this one, there's more that I want to say, but I'm going to try to stick to, I'm just going to kind of stick to the notes and what we talked about so far. I don't want to try to jump the gun. So let's see, how can we convert this guy into the standard form? So this is where, you know, your expertise on factoring comes into play. Some guy like this, what we want to do is complete the square, right? And I know that completing the square is one of those techniques that tends to give students a hard time. I do want to do a demo on completing the square, so that's what I'm going to do now. And so one of the first things whenever we do completing the square, that leading coefficient has to be a 1, right? So one way that we can go about making the leading coefficient a 1, we can factor out 2 from all the terms. So if we factor out 2, right, that's going to leave us with, we got this x squared plus 4x minus 5, right? Okay. So then with the part that's in the parentheses, that's the part that we want to do completing the square on. And so the completing the square step, we're going to add 0 in the form of plus b over 2 squared minus b over 2 squared. So if we add 0, it doesn't change the answer. What this allows, it changes the form. It changes the form into something that we can use, right? So again, the completing the square step, we're going to say plus b over 2 squared and minus b over 2 squared. Again, we're adding 0 in that form, okay? So in action, the first 2 terms stay. Now that we've gotten the leading coefficient to be a 1, okay? Now we're going to say plus, now our b in this case is going to be 4. So we're going to say plus 4 over 2 squared and minus 4 over 2 squared. That's the only manipulation that we did. Everything else is the same, right? So again, completing the square is one of those things. If you're not comfortable with it, either find another way or watch a few videos, or like, just try. If you just kind of like do a little bit of digging, watch a few videos and say, hey, how do I complete the square? Just watch a few of them, and then it gets to be kind of repetitive, and hopefully it will sink in and you can get it. This isn't the only way to kind of go about this, but if you have this at your disposal, then it makes things a little bit better, right? So now let's simplify these numbers, these results. I'm just bringing that down. So then 4 divided by 2 is 2, squared is 4. So really the 0 that we're adding, we're saying plus 4 minus 4, and then minus 5, okay? So now we have 5 terms in there. Now what the factoring technique I'm going to use is factor by grouping, right? I'm going to factor the first 3 by themselves and kind of keep the second 2 off to the side, okay? And also what I'm going to be doing is essentially distributing this 2. So let's see how this unfolds, okay? So then when we do this, we're going to have this 2 times x squared plus 4x. Actually, let me go ahead and factor that guy. So if we focus on the first 3, right? We're looking for 2 numbers that multiply to give us 4 and add to give us 4. I think those 2 numbers are 2 and 2, right? So that's going to factor into x plus 2 squared, okay? Now on the right-hand side, we got a minus 4 minus 5 gives us minus 9. If we distribute that 2, that becomes minus 18. Okay. So that was a demo on completing the square. Now, notice that this was equal to f of x. So I kind of did it a certain way. If you watch several videos on completing the square, they might do it a little bit different way. We added 0. That's the same as adding to both sides of the equal sign. I just did it this way because we had the f of x that we had to account for. If that was a number, then we could still do the same thing, but we could also do it a little bit different way as well. But again, my recommendation is to watch a few videos on completing the square. Just give it a try. If you're not feeling it, then try to find some other way. There are other ways to kind of go about these, right? Okay, so this isn't the graph. This is just the quadratic and standard form. So let me change this out. So this is like a checkpoint. So then in standard form, So now we can identify our h comma k. So remember, it's supposed to be x minus h. So that means our h comma k is what? -2, -18. Our a is 2, it looks like. Okay. So it looks like we're focused in quadrant 3 and the parabola opens upward. Okay. So I think I'm just going to do a rough sketch again. So say my positive x is in this direction. My positive y is in this direction. But I'm trying to focus on like quadrant 3. Oh, I found that's the man. Okay. All right, I'll take it. Again, this is my positive y. Can I like 3? It's kind of small. I feel like 4 is a little bit better. Okay. So -2, -18. Let me see. If I go 2, undo. If I go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, let's see if I can extend that. It's not snapping to the grid like it normally does, but I guess I can work with it. Okay. 2, 4, 6. That's fine. On the x-axis, like we can go by ones. I'm gonna go 1, 2, 3, 4. 1, 2, 3, 4, 5. Here's our origin. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. These are negative. These are negative. Okay. A little bit Jen, but it's okay. Okay. So we had a vertex of -2, -18. That'll put us about here. Let me see. We got our axis of symmetry. So that's snapped into the grid. There we go. Oh. Style. Nope. All right, that looks decent like that. This is x equals -2. Okay. So the -2, -18 puts us here. Okay. I'll label it -2, -18. Okay. And I think I'm just going to use my axis of symmetry. Let's see when x is 0. When x is 0, the corresponding y is -10. All right. So notice when we went 2 to the right, we're at -10. So that means when we go 2 to the left, we should also be at -10. So then that means -4, -10 is also a point on the graph. Let's see if we can find the x-intercepts. Let me see. So if we set y equal to 0, let me see. 18 divided by 2 is 9. That's a 3, plus or minus 3. So then -2 plus or minus 3. So it looks like it's -5 and 1. All right. So we should have this point here and this point here. Okay. So I kind of did it in my head, but again, all we did was set y equal to 0 and solve for x similar to the previous example. And then I'm just going to connect these guys with the smooth curves, as smooth as I can make it. Let me see. Let's see. You know what? I think they have a parabola tool. They do. If I can. Okay, it's not bad. It's just a little off because it's not drawn to scale. Right, like if I use graph paper or whatever, it'd be a little bit better. Okay. Okay, that's fine. That and like that. Okay. I think I'd like to confirm this with my Texas Instrument. Well, no, we got it typed. Let me just use the type notes. Okay, not bad. So again, just to kind of recap, we did a demonstration on completing the square. All right, and let me put that in the notes. We use completing Siri, spell the word completing.
Completing. C-O-M-P-L-E-T-I-N-G.
Okay. Sometimes, you know. Anywho. And let me highlight the completing the square step so that you know that that's what that is. Styles, purple, this one. Okay. So again, we use the technique of completing the square here. Okay. So then through completing the square, again, my recommendation, just watch a bunch of videos on it so you can get a good feel of that. That's something that we do expect you to already know coming in, but you know, just do your best. We got it in the standard form using completing the square, and then from there, we identified our vertex and our leading coefficient, axis of symmetry. The axis of symmetry is the x-coordinate of the vertex. In this case, that was x equals -2, yada, yada, yada. Okay. Let's see. So they identified their A, B, and C. Okay, so this is exactly what I wanted to talk about. I'm glad this was here, and I'm glad we took the time. So we use the technique of completing the square. There's actually another one that this is a shortcut, quote unquote. It's called the vertex formula, right? So where we use completing the square to find the vertex formula, I'll do that in, let's do it in orange right here. The vertex formula, right? The x-coordinate of the vertex is going to be -b/2a, right? So that's the shortcut I wanted to use. I wasn't sure how it officially showed up in the notes. So it shows up in this example. So what we could have done, identified our A and our B from the quadratic, and then use the vertex formula. That'll take us straight to the x-coordinate of the vertex, right? So our A in this case was 2, and our B would have been 8. So it would have been -8 divided by 4, which is ultimately -2, which is the x-coordinate of our vertex. Once we have the x-coordinate of our vertex, we take that, plug it back into the original to get the corresponding y, and then you can you could also build the standard form. Once you have the leading coefficient and the coordinates of the vertex, then you can just plug that into the standard form. So you don't necessarily have to do completing the square. That's what I was mentioning earlier, that this isn't the only way to go about this, right? So I'm glad that we did it different ways. We did it using completing the square. They did it using the vertex formula. You know, idealistically, you would be comfortable using both. Realistically, you know, you just kind of take whichever one you're more comfortable with and just kind of adjust on the go, whatever, right? And so here you can see the vertex formula and the things that we discussed. Yeah, that's fine in the x coordinates. That's fine. Excellent. The intercepts, axis of symmetry. So they essentially did the same stuff that we did. Kind of took a few different routes, but you know, the same thing. We got just under 10 minutes. So it says the graph of this function is shown. Find the domain and range, and then solve this inequality. We're actually almost done. Makes me a little bit nervous. My later classes tend to go a little bit faster, but that's okay. Because I'm thinking even less than I am with you all. Okay, find the domain, right? The domain and the range. So in a graphical sense, the domain is going to be the very left to the very right. Right? So we ask ourselves, how far left does this graph go? How far right does this graph go? All right. So notice at the bottom, you know, we have these arrows, right? It just means continue the graph, continue those patterns in that direction. If we were to take this image and smush it onto the x-axis, what x values would it touch? Keep in mind the arrows go on to infinity, right? So it's going to touch all the x-axis, all the x coordinates, right? So the domain in this case would be all reals, negative infinity to infinity. Infinity always gets a parentheses in this context. The range is going to be the very bottom to the very top. How far down does this graph go versus how far up does the graph go? The very bottom in this case would be negative infinity. The very top would be, it goes up to a y value of 3. Infinity always gets a parentheses. We actually reached 3, so we're going to use a square bracket there. Okay. Another way you can visualize this, it's called a projection. If you were to take this image and smush it onto the y-axis, what y values would it touch? All right, that's called a projection. Another way you can visualize it, if you were to take a light source, if you're doing range and put it to the right or the left and you cast a shadow, what values on the y-axis would the shadow touch, right? And also kind of keep in mind that the rays of the shadow would be like either parallel or vertical, nothing diagonal, right? So it's not like the whole Coriolis effect. If you don't know what the Coriolis effect is, look it up. It's an interesting little thing. It leads to some pretty trippy conclusions. Yeah. So, but yeah, just look up the Coriolis effect. But you know, none of that would happen here anyway. You can forget all that for now. So then we're asked to solve this inequality. It's basically saying, when is this quadratic positive? In other words, when is it above the x-axis? Well, we could just look at the graph and see, oh, it's above the x-axis. They give us the x-intercepts 4 plus or minus the square root of 6 over 2. So it's basically between those. So then for B, the solution would be all points between. If you want to be strictly above 0, the left end point would be 4 minus the square root of 6 over 2. The right end point would be 4 plus the square root of 6 over 2. And we would use parentheses. So we're basically talking about all the points in between. Oh, is that this week? Is this week homecoming? Let me see. It should be. Yep. Nice. You guys catch me out there on Saturday, turn it up. That would be hilarious. Okay, anywho. Yeah, this looks good. If we wanted to solve that inequality algebraically, yeah, we would treat it like an equation, solve for the x-intercept. So we could either use a quadratic formula, completing the square. We would just need to solve for those. We can generate those either from the quadratic formula or completing the square. I'm not sure this guy could be factored like that. And then you would choose test points, right? So once you have your x-intercepts, you choose a point to the left of your x-intercept, in between your intercepts and to the right. And then wherever it's positive, that's what, you know, that would tell you what interval. Okay, let's see the way the textbook did it. Yeah, that's fine. The graph is above the x-axis in the interval. Yeah, that's fine. Okay, we got like 3 minutes. Find the dimensions of a rectangular garden of maximum area if the perimeter of the garden is 80 feet. What is the maximum area? Let's see how quick. We got like a full 3 minutes. It says a rectangular garden. So let's start with the rectangle. Okay. Let's say this is the length and the width. We're asked to maximize the area. They're asking us to maximize the area. Okay. It says the perimeter of the garden is 80 feet. So the perimeter is 80 feet. Okay. All right. So let's see perimeter. All right. So basically the distance around the outside. So that means we have a W over here as well and an L over here as well. Okay. So let's write that out. So then 2W plus 2L would equal 80. Okay. So let's let W be X, right? So then that means that L will be what? Okay. So let's do the substitution here. So we have 2x plus 2L equals 80. So we can isolate L there. We can solve for L there, right? So then 2L would be 80 minus 2x. Here, instead of, let me back up a little bit. Let me back up. Instead of introducing x, that was weird that it changed. Oh, you know, that's probably a setting. I did put that back. Anywho, let's just solve for L in terms of W, right? So if we solve for L, 2L equals 80 minus 2W, okay? Divide both sides by 2, so then the length is going to be 40 minus W, okay? So then if we want to, let's see if we can get an expression for the area. Area is length times width, so that's going to be the 40 minus W times W. That's the length times the width, okay? And then if we keep going, if we distribute, we're going to have negative W squared plus 40W. Let me see the time. Oh, I got less than a minute. Okay. So then notice that this is a parabola, right? We can express the area in terms of W. The highest power is a 2. So that means it's quadratic. The leading coefficient is negative, so it should open downward. The max should occur at the vertex of the parabola, right? So we can use the vertex formula. The x-coordinate of the vertex, which is h, is going to be negative b over 2a. Okay. So that's going to be a negative 40 over 2 times negative 1. It's going to occur when our width is 20. Okay. So our claim is that the maximum of the area is going to occur. What is the maximum area? Okay. All right, I think we have everything. I'm just trying to wrap this up. So then it looks like the maximum area occurs when the width is, what, 20 feet. If the width is 20 feet, then that means the length looks like it's also 20 feet. And the maximum area let me see. 40 minus 20 is 20 times 20 is 400. 400 square feet. Okay, kind of out of space. Let me see. I'm not filling it. I'll just move this. Nope. Trying to get you guys out of here. I see the time. Give me just undo. Give me just a moment to wrap this up. And we'll do some closing remarks and I'll get you out of here. Okay, so that's the result we got. Let me kind of check my prepared notes. Yada, 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 yada. Oh. Yeah. So the maximum area K of the rectangle is 400 square feet, 20 by 20. Okay. All right, gentlemen. Are there any burning questions before we go our separate ways? While I make a copy of this available. Let me just make a copy available. Additional notes. Okay. Choose a folder. That's fine. Upload. Might be missing an assignment. That's okay. Because I don't think we really wrote anything. All right, gentlemen. All right, if there aren't any burning questions, so on Wednesday, what we'll do, we'll go through as much of the corresponding homework, together. If there are any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day, and we'll meet back on Wednesday, same place, same time, same place. Take care. Peace. hopefully you guys be sure to enjoy your homecoming, right? Hopefully get your work done, do what you need to do, but maximize your experience. The experience is what you make it, right? It's all in your whole. This life is based on what you choose, right? Even when you come against obstacles, that's part of our divinity. We have the power to like take charge of our experience, right? So if we want to have a different experience, then we just got to make different choices. Change our thought. I know that sounds overly simplified, but that's really at the crux of it, at the meat and potato. So, all right, guys, take care. Till next time. Let me kind of check on you guys before I close everything out. Chats. How is the A? Oh, that was a while ago. How is the A left alone? Hopefully, the answer that question got answered. All right, guys.